Hello, grade 11s. I hope that you are also excited about this afternoon's functions. On Monday, we will start with the normal e-learning classes in the mornings, Monday morning and Monday afternoon again, because you're almost going back to school. I hope that you're also excited about that. Okay, now yesterday I said I'm going to show you today how to find the equation if you have the graph. So now it's the other way around. You don't have the equation and you have to draw. You have the sketch and you have to find the equation. So now the question is, determine the equation of a parabola, of this parabola, in the form y equals ax squared plus bx plus c. Now, you must remember, they are going to ask you 90% of the time, they're going to ask you to get the equation in this form, but you're never going to start there. Well, 99.9% of the time, you're not going to start there. You first look at your sketch. Now, can you remember, I'm just going to write the three forms. It was this one, and then it was the one ax minus p squared plus q, where pq was the turning point. And then you had the equation y equals a x minus x1, x minus x2, where x1 and x2 were the x-intercepts. That was the three equations that you had. Number 1, number 2, and number 3. Now they're going to ask you in the form of the first one, but you're not going to start there. Depending on the sketch, you're going to decide, if I have the turning point, I'm going to start with equation number 2. If I have the x-intercepts, I am going to start with equation number 3. Now, if you look at this sketch, can you see what you have? You have the two x-intercepts and another point. Now, remember what we said all the time. We said that this x and this y were the coordinates of any point on the graph. Now, that's why it's important now. You have the two x-intercepts. So you're going to start with the equation where you use the x-intercepts. So I'm going to start with equation number 3. So I'm first going to substitute the x-intercepts because I know that's minus 3 and 4. So it's x minus 3 and x minus 4. And what am I going to do with this x and y? I'm going to substitute the other point that I have. So in the place of y, I substitute minus 20. In the place of x, I substitute the 2 y, because now I can solve a. So that will give me a times 5 times negative 2. Sorry, a. So that will give me minus 10a equals minus 20. If I divide the minus 10 away, I get a equals 2. Now always make sure the a is positive in this case. Do I have a smiley parabola? Yes, I do. So now I know the chance that I'm correct will be very good. So now I can carry on. So now you take your equation where you substituted the x-intercepts, and you're going to substitute the a, this a I'm going to substitute with 2, and then this x plus 3, x minus 4, I am going to multiply, because if I multiply and simplify, I'm going to get this form. So that's what I'm going to do now. So multiply the two brackets. Remember, you must FOIL. So that's x squared minus 1x, because it's minus 4x plus 3x, And 3 times negative 4 is minus 12. If you now multiply in the 2, you have 2x squared minus 2x minus 24. Okay. Now there's the form that they asked you. They asked you for y equals ax squared plus bx plus c. And can you see? There's the a, there's the b, and there's the c. So now you're done. Okay. So you're not going to start with the one that they're asking you. You're first going to check, do I have the x-intercepts, because then I'm using equation 3, or do I have the y-intercept, because then I will start with equation 2. Okay, number 2. Now look at your sketch. Can you see that the turning point are given? Determine the equation of a parabola, and they again ask in this form. But you're not going to ask to start there. You're going to start with the equation that uses the turning point. So it will be y equals a x minus p squared plus q. Can you see why I said yesterday you need to know the equations by heart? It's not on a formula sheet. So now the turning point is minus 1/8. So I'm going to substitute the turning point. The p value is minus 1 and the q value is 8. But what did we say yesterday? What does this x and y stand for? Any point on the graph. And there I have another point 2 and minus 10. So I'm going to substitute the x with a 2 and the y with negative 10. 2 plus 1 is 3. 3 square is 9. So I have 9a equals negative 10. And if I take that 10, that 8 to the left-hand side, it becomes a minus 8. So minus 10 minus 8 is minus 18. That gives me an a of negative 2. Now check your sketch. A negative a gives you a sad parabola. Is that what you have? Yes. So now you think that you're correct. Now you substitute back. So y equals the a you substitute with minus 2x, and the p you substitute with minus minus is a plus 1 squared, and the q is plus 8. Just to remind you of yesterday's class, can you remember I said if there's a minus, then the turning point will be a plus, and there you can see it. If there's a minus 1, there will be a plus. And the q value is exactly what you have for the turning point. And now I'm going to simplify. Now remember, a 2-term squared gives you a 3-term for an answer. You must expand and FOIL. So that will give you x squared plus 2x plus 1 plus 8. Multiply in minus 2x squared minus 4x minus 2 plus 8. So it's minus 2x squared minus 4x plus 6. And if you look at your sketch, can you remember that we said this C means the y-intercept? And can you see that it makes sense that the y-intercept will be 6? So if you see stuff that confirm your expectations, then you know that the chances are very good that you are correct and you can just carry on. Okay. Number 3. Number 3 is a sad parabola. Now they gave you the point A is the y-intercept. And the y-intercept is at 1. And there they're giving you the point B, which is the turning point, which is 1 and 3. So what do you have? You have the turning point and another point. So you're going to start with the equation where you have the turning point. Substitute, you want to calculate A. You know that X and Y are the coordinates of any other point. Now you must realize that the y-intercept that they've given me here has coordinates 0 and 1. It was not given explicitly. It was just given that it's the y-intercept. So you substitute the x with 0, the y with 1, minus the turning point P is 1 squared, and the q value, the y value of the turning point is 3. So that gives you minus 1 square is positive 1 times a is 1a. If I take the 3 to the left-hand side, I get minus 3. Is it a sad parabola? Yes, it is. So now I substitute again into my original equation. So y equals a, I calculate it as minus 3. X stays x and y stays y, because that stands for all the, minus 2. 1 minus 3 is minus 2. Thank you. Minus 2, and there is a minus 2. And then x, and there is a minus 1 again, plus 3, and now I expand again. So it's minus 2x squared minus 2x plus 1 plus 3. Multiply the minus 2 in, minus 2x squared plus 4x minus 2 plus 3. So that will give me minus 2x squared plus 4x plus 1. And can you see again, there's the plus 1. There's a plus 1, which is the y-intercept, and there you can see, yes, the y-intercept is a plus 1. Okay. Let's look at number 4. Now, if you can't see it clear, I will show you. This is an x-intercept of minus 1 and an x-intercept of 2 and a point 3 and 8. So what was given? The x-intercept. So I'm going to start with the equation where I use the x-intercepts. So y is 8 and the x values 3. What's the x-intercept? Minus 1, so minus 1 there and 2 there. So that gives me a times 4 times 1 equals 8. So if I divide that 4 away, I get a equals 2. Can you see it's a smiley parabola? A is positive, so I can carry on. So I substitute back. A is 2. I keep the xx. Now it's minus 1, which gives me a plus 1. It's x minus 2 here. And I must just simplify. If I expand FOIL, then I will get x squared minus 2x plus 1x is minus x. 1 times minus 2 is minus 2. And if I multiply in again, I get that. And if you check the sketch, remember we said this is the y-intercept. And look here, there's the y-intercept, which is equal to minus 4. Good. Now they can also ask you something like this. The graphs of fx equals ax squared plus bx plus c and gx equals k to the x plus q are given. Find the equations of f and g. So now you see that f is the parabola and g is the exponential graph. So let's take one at a time. Let's see if we can start with f. What do I have? I have the x-intercepts and another point. So I'm going to start with y equals a, x minus x1, x minus x2. The a is what I want to calculate. X and y, I'm going to substitute with a point 0 and 3. And the x1 and the x2 are the x-intercepts, so it will be minus 3 and minus 1. So that gives me a times 3 times negative 1 equals 3. So there I'm going to divide with a minus 3, divide by minus 3, so a equals minus 1. And can you see it's a sad parabola, so the a value must be negative. So now I substitute back. Y equals, the a value is minus or minus 1. X minus minus 3 become a positive 3, x minus 1. If I FOIL, I get x squared minus x plus 3x is plus 2x minus 3. And I multiply in the minus, that gives me minus x squared minus 2x plus 3. Okay. And there you can see again, your y-intercept is 3, and there you can see your y-intercept is 3. So it makes sense. Okay, now let's see the G graph. Now the G graph they gave me is the equation k to the x plus q. Now you remember that q is the asymptote. But do you have the asymptote? No, you know that the asymptote is there, but you don't know what is the asymptote, where it goes through. You don't know the value of k, although you know that k will be between 1 and 0, a fraction less than 1. But you know that x and y are the coordinates of a point. Now, if you look at your exponential graph, can you see that you have the point C? So you're going to substitute that point. So y is 3 and x is 0. Now it looks as if you still have two unknowns, but you actually don't, because what's anything to the power of 0? Anything to the 0 is 1. 1 plus q is equal to 3, so that gives me q is equal to 3 minus 1 is 2. So it makes sense. So that asymptote goes through y equals 2. Okay, so I can substitute the q. So if I substitute y equals k to the x plus 2. Now I still need to find k. Oh dear, now I have a problem. Because the one point that I have on the equation, on the graph, I used already. I cannot use the a or the b because they are not on the exponential graph. So now it looks as if I have a problem. But do I really have a problem? No, that point which is the turning point of the parabola, is also a point on the exponential graph. So can you calculate that turning point first? Yes, because you know how. So that means you must go back to the parabola and you must calculate the turning point. So for the turning point, you remember you use x equals negative b over 2a. Can you remember I said you must know this formula because it's not on any formula sheet, you must know it. So can you see that you need it now again? So b is negative 2, is my b value. A is negative 1. That gives me an answer of negative 2, positive 2 divided by negative 2, which is minus 1. But now I still need to find the y coordinate of the turning point. And how do I do that? I substitute my x coordinate back into the x. So it's minus 1 squared minus 2 times minus 1 plus 3. So remember you square before you multiply. So minus 1 square is 1 times a negative is minus 1. There I have plus 2 plus 3. So that gives me 5 minus 1 is 4. So the turning point is the point minus 1 and 4. And now I can use that turning point, which is negative 1 and 4, to use as the other point that I need to find my equation. So now I can substitute this point in the place of that x and y. So I'm going to make y 4. I'm going to make x minus 1 and then plus 2. If you simplify that, what is k to the minus 1? K to the minus 1 is 1 over k. You remember the law. And then 4, if I take this 2 to the left-hand side, I get 2. Now, what did we say? If you're working with fractions, make everything fractions. So make this 2 a 2 over 1, because then you can cross multiply. So now I can say 2k is equal to 1. So therefore k is equal to a half. Does that make sense? Yes, because we said this is a decreasing exponential graph. And can you remember we said decreasing is the one where the k is between 0 and 1. Now this is what I call theory. Can you see, if you know the theory, you can see if your answers will be correct or incorrect. If you don't know that the decreasing graph has a value of something, a fraction between 0 and 1, then you will not know if you are correct. So the more you know, the less mistakes you will make. So now I can write my equation, y equals k to the x plus 2. Now, what I've written there, if it was my learners, I wouldn't give them a mark, because what does this look like? It looks like if it's 1 to the x. 1 to the x is 1. So what must you remember? If this is a fraction, you must put it in brackets. You must put it in brackets, because otherwise it looks like you just raise the 1 to the power of x. Okay. Okay, now I've told you yesterday that I'm going to give you the parabolas and you are going to find the equations. But now I want to also show you, because we didn't do that yesterday or the day before, Yesterday we did the horizontal shifts for the parabola. Now I want to do the horizontal shifts for the hyperbola, because that's part of the grade that's part of the grade 11 work. Okay. Now, can you remember the grade 10 graphs that we revised was just y? It was just y equals a over x plus q. And we said that this q gave me the horizontal asymptote. Can you remember that? And we just did it with the previous one as well. That q value there gave us the horizontal asymptote. There you see it. Okay. And we said that the y-axis was the other asymptote. If I had an hyperbola that say looked like that, can you remember? The y-axis was an asymptote and the x-axis was an asymptote. Now then we added something here, there. So now we have another horizontal asymptote, and we said if Q is positive, the graph moved up, and if Q was negative, the graph moved down. That's the vertical shift. So the horizontal asymptote moved up, and with that, the graph also moved up. But now, if I have something here, it means the graph shift to the right or to the left. Horizontal shifts, sideways shifts, sideways. Now I remind you of what we said yesterday. Like the X factor, like the men always otherwise. So if you have a minus, the graph shifts to the right. And if you have a plus there, the graph moves to the left. Because how it works is this x minus p, if you make it equal to 0, then x become positive p. Can you see that? And that x equals positive p is the vertical asymptote, the new vertical asymptote. So if I move, say I move my vertical asymptote to the right, it will be because I have a minus there. But then the whole graph also moves to the right. And can you see where I only had a new x-intercept, because I have a new vertical asymptote, I can have a new y-intercept as well. I have an x-intercept and I have a y-intercept. So you start with the asymptotes, the vertical asymptote, which you get from Q. Then you do the horizontal asymptote. Now you do the vertical asymptote, which you get here. And remember what we said. If you subtract from the x, the graph moves to the right. If you add to the x, the graph moves to the left. It feels wrong. But remember what we said, like the X factor, always otherwise. Why does it work the other way around? Because you make that X minus P equal to 0 and X become positive P. And then, of course, you must calculate the new X-intercept as well as Y-intercept. And you know from the previous days, to find X-intercept, you make Y0. To find Y-intercept, you make X0. So let's do this number 6 as an example. Draw y equals 2 over x plus 1 minus 1. Now we said okay, the shape stays the same. So remember, this one gives you the shape. So the shape tells you that the hyperbola will be in quadrant 1 and 3. Then you carry on to the asymptotes. Now you have a new vertical asymptote and a new horizontal asymptote. So this one gives you the horizontal asymptote. So sometimes they abbreviate it like that, horizontal asymptote. Horizontal asymptote will be y equals minus 1. And then we said this one gives you the vertical asymptote. Now remember what I said, if there is a plus, then the asymptote will be x equal to minus 1. Why is it like that? X plus 1 is equal to 0, so therefore x equals negative 1. So if you start drawing, you will draw the asymptotes first. And remember, asymptotes you show with dotted lines. Y equals minus 1 is this one here. Horizontal asymptote through the y-axis at minus 1. And then x equals minus 1 is the vertical asymptote through x equals negative 1. So this one is x equals negative 1. And write the asymptotes, the equations on the asymptotes, because then nobody can penalize you. You don't want to be penalized at the end of the year. So the more correct your work, the less chance for penalization is there. Okay, now that too tells me that the hyperbola will be somewhere here and somewhere here. Okay, but now the problem is, can you see there's an x-intercept and a y-intercept? And I want to know that. So that means I must first calculate them. So you're going to calculate the y-intercept by making x, x0. So y equals 2 over, I make that x0, 0 plus 1 minus 1. So that gives me 2 minus 1 is 1. Okay, so the y-intercept is 1. And then I must still calculate the x-intercept. And you know how to calculate the x-intercept. For x-intercept, you make y0. And you have 2 over x plus 1 minus 1. So you take this minus 1 to the left-hand side, it becomes a plus 1. And what did we say? If you're busy with fractions, make this number a fraction by putting it over 1, because then it's easier. Then you can cross multiply. 1 times x plus 1 is x plus 1. 2 times 1 is 2. And you get x equals 1. So now you know the x-intercept is 1. And now you can draw this part of the hyperbola. So you get horizontal shifts, sideways shifts if you add or subtract something to the x, and remember x factor, like the main always otherwise. If you see a plus, the graph moves to the left. If you see a minus, the graph shifts to the right. Okay, and if you start drawing at the asymptotes, you will not make mistakes. Okay, let's do another example. Oh, you know what? Before we do the example, let's just quickly write the domain and the range. Because, can you still remember? The domain, the x's come from minus infinity and it goes to positive infinity. So it's x element of all the real numbers. But do you still remember that you must exclude the asymptote with an x in it? Because the graph is not at the asymptote. So remember to exclude x equals -1. And then the range, can you remember I said they love asking domain and range for the hyperbola because you forget to exclude the asymptotes. The hyperbola comes from negative infinity, it goes to positive infinity, so it's still y element of r, but don't forget to exclude the asymptote that says y equals. So y not equal to, and that is also a -1. And can you see this is the decreasing hyperbola? It's decreasing, it's decreasing. So the whole hyperbola is decreasing. Okay, let's do the same for number 7. Draw y equals -4 over x -1 plus 2. First of all, you must know that's a hyperbola. You know that this plus 2 will give you the one asymptote. Oh, okay, let's start with the shape. So the shape, your A value is a -4. So your hyperbola is in the second and the fourth quadrants. In other words, the increasing one. Asymptotes. This Q gives me the horizontal asymptote, which will be y equals 2. This x -1 will give me the vertical asymptote. X -1 equals 0, so x equals +1. And if you want to draw, you always start with the asymptotes in any case. So y equals 2, remember dotted lines. So y equals 2 is above the x-axis somewhere there. Y equals 2. X equals 1, so it's this side of the y-axis. X equals +1. Now the hyperbola shifted up and to the right. So that means I will have a y-intercept and I will have an x-intercept. So I must calculate. So for y-intercept, make x0. -4 over 0 minus 1 plus 2. So that gives me -4 divided by -1 is 4. 4 plus 2 is 6. So there's a y-intercept of 6. I must calculate the x-intercept as well. for x-intercept, can you see that I'm working neatly? I'm working in a specific order. I have my recipe and I follow the same recipe all the time. And people, if you do that with maths, then maths really get simple. If you know your recipes, you can do maths. Okay, so for x-intercept, you make y0 and you just simplify. So you have x minus 1 plus 2. First take the 2 to the left-hand side, minus 2. Cross multiply by first making the minus 2 a fraction. Now you can put that minus at the top or at the bottom or in front. It really does not matter. Now let's keep it where it is so that I don't confuse you. Minus 2 times x is minus 2x. Negative 2 times negative 1 is positive 2. Minus 4 times 1 is minus 4. If I take this 2 to the other side, then I have minus 2x equals minus 4 minus 2 is negative 6. And if I divide by minus 2, now I get x equals positive 3. Positive 3. Ooh, does that look right? Yes, because my 1/2 is here. So there's my 1/2. And there's my other half. So my other half, let's go there. Yes, and there's my hyperbola. And if they ask you for domain, then you can say x element of, if you don't want to write x element of R and you write minus infinity to positive infinity, that's fine. But remember to exclude the asymptote that says x equals. And the range comes from minus infinity to positive infinity. So it's again y element of minus infinity to positive infinity. Remember, if you use the infinity signs, you must use a round bracket. And you must remember to exclude the asymptote that starts with a y. And can you see that this is an increasing graph? If you hit it from the left, you go up. If you hit it from the left, you go up. So if they ask you, okay, let me write it for you, for which values of x is the graph increasing? Now, where's that? That's everywhere. Everywhere. Now, how do we write everywhere in maths? X element of real numbers. But what about the asymptote? Is the graph increasing at the asymptote? No, there's the asymptote. Where's the graph? Well, I don't know. It's not there. So the same as with the domain and the range, you must remember to exclude the asymptote because the graph is not there. And if you do that, you will not lose marks. Okay. I want to do the same with the exponential function. Because we said we had y equals a to the x plus q. Okay. And we said that this q was the asymptote. Now that's still the case. That's still the case. This plus q will give me the, which asymptote? There's only a horizontal asymptote. Horizontal asymptote. And that will be y equals q. The A is still the shape. The A is still the shape. Uphill if A is bigger than 1 and decreasing when A is between 1 and 0. X and Y are still the coordinates of any point on the graph. But now what do you see here? There you see a minus P. That means the graph shifted to the left or to the right. So again, let me take another color. There's a minus P. So that P tells me the graph moved sideways. It's a sideways shift. But now, because you added or subtracted from the X, it's like the men always otherwise. So if you have a minus there, the graph moves to the right. And if you have a plus there, the graph moves to the left. Remember, like the men always otherwise, that's just a joke to help you remember that if you add to an X, you move to the left. If you subtract from the X, you move to the right. It's not an asymptote. Remember, it's not an asymptote because the exponential graph does not have a vertical asymptote. And the only way that you will see that the graph moved is with the y-intercept. And you don't have to worry about that because you're going to calculate that. So if we take an example, draw y equals 2 to the x plus 1 minus 8. So that 2 gives you the shape. And because 2 is bigger than 1, it will be the increasing function. What does this minus 8 tell me? It tells me the horizontal asymptote is y equals negative 8. And you remember that you always start drawing with the asymptotes. You start with the asymptotes. So y equals minus 8 is something like that. Y equals negative 8. Now it's an increasing graph. So can you see that because it's an increasing graph, there can be a y-intercept and an x-intercept? So that means I want to calculate before I can draw. So I am going to draw, calculate the y-intercept as usual by making x 0. So y equals 2 to the 0 plus 1 minus 8. 2 to the 1 is 2. 2 minus 8 is minus 6. So there at minus 6 will be my y-intercept. Then I must still calculate the x-intercept. And how do I do that? Can you hear the recipe stays the same? I make y 0 and I calculate x. Now, can you remember how you solve exponential equations? If I take this negative 8 to the left-hand side, how do you solve exponential equations? You either get the bases the same because then the exponents are the same, or you get the exponents the same because then the bases are the same. Now, can you change this 8 to a 2 to the something? Because here you have 2 to the. So can you change 8 to 2 to the something? Yes, 2 to the 3. And because 2 to the 3 is equal to 2 to the x plus 1, I can say that 3 equals x plus 1. The exponents are the same. So therefore, x equals 3 minus 1 is 2. And there's my 2, my x-intercept. And can you see? There's my equation, my graph. So it's really not difficult as long as you follow the recipes. If I ask you the domain, can you see it comes from the left-hand side, from minus infinity. It goes out forever, so it goes to positive infinity. So it's x element of R. Is there an asymptote that says x equals? No, so there's nothing to exclude. A range? Well, if you come from the bottom, from minus infinity, where's the first place where you will hit the graph? Just above the asymptote. So can you see it's the y values bigger than minus 8. Or if you want to write it as y element of the smallest value is just above minus 8. So it's minus 8 but not included. And then it goes up to infinity. And this graph is increasing for all real x's, for all x element of R. This is an increasing graph. Okay. There's another one. First of all, you must see y equals 3 to the minus x minus 2 minus 1. So you must first realize this is an exponential graph. So this minus 1 gives me the asymptote. So it's a sorry, we must first start with the shape. The shape, we said, check for the shape. Oh, now be careful. 3 to the minus x. Can you remember what we said yesterday or the day before? 3 to the minus x, I can write as 3 to the minus 1 to the x. And that's the same as a third to the x. And if you know that, then you see, okay, this is a third, means a fraction less than 1. So this is a decreasing graph. Okay. Minus 1 is the horizontal asymptote. So what's the horizontal asymptote? Y equals negative 1. So if I want to draw that so long, y equals minus 1 will be there. Y equals minus 1. And remember, asymptotes with dotted lines. Okay, now I want to calculate the y-intercept by making x0 So I have 3 to the minus 2 here. What is 3 to the minus 2? 3 to the minus 2 is 1 over 3 to the positive 2, which gives me 1 over 9 minus 1. And if you calculate 1 over 9 minus 1, you get minus 8 over 9. So there is your y-intercept, minus 8 over 9. Now I must calculate the x-intercept. And how do I calculate x-intercept? Make y equal to 0. Then you have 3 to the minus x minus 2 minus 1. And solve. Take the 1 to the other side. Then you have 3 to the minus x minus 2. Now, I don't think there's a mistake here. Because how do I get a 1? 3 to the what is equal to 1? You remember the law that says anything to the power of 0 equals 1. So you can do it in two different ways. You can change this 1 to a 3 to the 0. Because then your bases are the same. That means the exponents are the same. Or you can simply say, you know what, anything to the power of 0 is 1. So what I have here, minus x minus 2, must be equal to 0. I solve that and I get x equals minus 2, x equals negative 2. Oh, yes, and it is a decreasing graph. So there's my exponential graph. And again, if they ask me the domain, then I say x element of all the real numbers because it goes from minus infinity to positive infinity. And the range, now the graph, the first time I will hit the graph is just above minus 1. So it will be y bigger than minus 1, or if you want to say y element of minus 1 is my smallest value, but excluded because there's an asymptote up to infinity, and this is a decreasing graph. Okay, that's all for today. I see you then on Monday when you are at school again in your maths class, either 8 o'clock on Monday morning or 2 o'clock, no, 3 o'clock. And then we will be doing trigonometry equations, if I remember correctly. Okay, it was nice to have you. Enjoy the weekend, keep safe, and then I see you on Monday again. Bye-bye.